Part 2 of Organic Chemistry, which involves naming compounds. The first rule that you need to know when naming compounds is the prefix of each one. The first one being met, then eth, then pro, but, pent, hex, hept, oct, non, dec. Then you add the appropriate word at the end, depending on the compound. A way to remember this in order is mother elephant pulls baby pigs home, however, only Nonda drives. These are 4 basic steps of naming the compounds. You first have to identify the longest carbon chain. The second, you need to describe the branches. 3, label or the numbering. And 4, you always start with the lowest number when you start to name the compounds. Here are basic rules for naming the compounds. The previous slide was steps. Identify and name parent chain. Identify and name the branches. Number the carbons in the parent chain from the end that gives the lowest number. Branches go in alphabetical order, meaning ethyl, methyl, then propyl. If there are more than 1 branches in equivalent positions, assign the lowest number to the one that will come first in the alphabet. If the same type of branch occurs more than once, the location of each point is given, and the number that occurs is indicated by di, tri, tetra, and so on. Here are a few examples that we will be trying to do together. The first step is to always count the number of carbons. 1, 2, 3. Therefore, it's pro. This compound has only single bonds, so it'll be an alkane. That's why it's a propane. However, there's a branch that sticks out, which has 1 carbon. That's why it's a methyl. This methyl sits on the second carbon. Hence, 2-methyl propane. The next one you count. 1, 2, 3, 4, 5, 6. Hex. However, there's a triple bond, so it'll be an alkyne. Hex -1 -ine. The last one on the slide is 1, 2, 3, 4. Bute. There's a double bond now, which is an alkene. So you're going to say bute-1-ene. Pay special attention to this one. You don't say bute-4-ene, you say bute-1-ene. Because you always count from the lowest side. So you count from 1, 2, 3, 4 and not 1, 2, 3, 4 because you count closest to this bond here. We'll do these together as well. It's a double bond O at the end, so it's an aldehyde. 1, 2, 3, prop, propanol. It's haloalkane. You'll start. This one's already done nicely for you. You'll start 1, 2, 3, 4. The Br sits on the second one. It's a alkane, so it'll be 2-bromobutane, since there's 4 carbons. Bromo, because there's a Br. This one is a haloalkane as well. However, this isn't done for you. Here's the Cl. We'll count 1, 2, 3, 4, because this needs to be the lowest number. So it's on the second one, and there's 4. So it's bute. So you'll say 2-chloro, because this is a Cl, butane. Before we do these together, I want you to take a piece of paper and a pen and write them down and see if you get them right. So pause the video and try them. We'll be moving on and seeing if you get these correct now. The first one is an alcohol, since there's an OH. 1, 2, ethanol, because it's an alcohol. The next one, 1, 2, 3, 4, 5, pent. There's an OH and a double bond O, meaning a carboxylic acid. So it'll be pentanoic acid. The last one is 1, 2, 3, 4. However, this is tricky. There's a double bond O and there's another O, which shows you this is an ester. So 1, 2 is before this O and 1, 2 is after the O. So it's ethyl ethanoate. Past paper examples. I want you to pause the video again and try them yourself. The first one we're going to count 1, 2, 3 because there's a 2 in small, 4, 5, 6, 7, 8. So you know this is oct. They are all single bonds, so it'll be an octane. However, there's 2 BRs sticking out, which tells you it's a haloalkane. The BRs sit on 1, 2, 3, 4. Then you tell yourself no, because there's the BRs 1, 2, 3. This is the closer one, so you start counting this way, not this way. So you're gonna come 1, 2, 3, 4, 5. It sits on 3 and 5. There's 2 BRs, so it'll be dibromo. You put 3, 5 dash dibromo-octane. The next one, we're gonna count as well. 1, 2, 3, 4, 5, 6. You know, it's a hex. Hexane, since they are single bonds. There's a bromo that sticks out. You count from this side since it's closer this way. So you can go 1, 2. The bromo sits on the second one. You're gonna go 2 dash bromo. However, there's still branches that are sticking out. Yeah, and yeah. This is the second one, third, fourth one, and the fifth one. There are branches on 2, 4, and 5. It's a methyl since there's 1 C. There's 3 methyls, so you put it together. Trimethyl hexane. The last one is an ester. You count before the O and after the O. You know it's an ester because of the double bond O and the single bond O in between. You count 1, 2, 3, and 1, 2, 3. So it'll be propyl propanoate. Pause the video before you look at answers. The first one is a carboxylic acid because of the double bond O and the OH. You count 1, 2, 3, 4, or you can count 1, 2, 3, 4. Doesn't really matter, we'll go this way though. So, it's important to count 1, 2, 3, 4 and not 1, 2, 3, 4 because it's closest here and you always start with the lowest number. So, you count 4, so it's butanoic acid. However, there's still branches, 1 here, and 1 on the side. The branches, there's 3, so it's trimethyl. Now you just have to find the position. There's 2 here, so that's why it's 2, 2, and there's 1 here, 2, 2, 3. The next one you have to draw, so it would look like this, which is easy to see. This is condensed structure formula. You see 6, 1, 2, 3, 4, 5, 6. Hex. And because of the 3, it'll be an E. However, you need to draw this out to see it. The next one you also have to draw. You have to draw 5 carbons and attach H's to all of them. And you will see what you have. This one, since there's 5 carbons, it's pent. And it's pentanel because it's an aldehyde. That means there's a double bond O at the end or the beginning. Pause the video and try yourself. The first one is 1, 2, 3. Prop. There's a double bond O and there's OH, meaning a carboxylic acid. Therefore, propanoic acid. The next one, 1, 2, 3, 4, 5, 6. Hex. All single bonds, hexane. Then there's a Cl here and a Br, and there's one branch that sticks out. 1, 2 is where the methyls are. 2-methyl hexane. Then on the second one as well, there's a chloro. It's 2-chloro. And 1, 2, 3, 4, 5 is where the Br. Therefore, 5-bromo-2-chloro-2-methyl hexane. The last one is 1, 2. Ethane. There's a Br and a Cl. The Br sits on the first one, so it'll be 1-bromo. Then there's 2 Cl, so it'll be dichloro, and it sits on the second one. Thus, 2,2-dichloroethane. Don't forget to try yourself first. The first one, 1, 2, 3, 4, 5, 6, hex. It's the double bond sits on the first carbon, meaning an aldehyde, so it'll be hexanyl. The second one, 1, 2, 3, 4, 5, 6, hexane. However, there's 2 ethyls because there's 2 carbons, meaning 2 ethyls. And it sits on the third carbon. So 3,3-diethyl hexane. The last one, 1, 2, 3, 4, 5, 6, hex. Now, there's a methyl here and there's a methyl here. So it's 1, 2, 3. So 2-3-dimethyl hexane. Di because there's 2. And on the fifth one, this sits a Br. So it'll be 5-bromo-2,3-dimethyl hexane. The first one, we're going to be counting 1, 2, 3, 4, because this is where you need to start from. Bute, and it sits on the first carbon, meaning an aldehyde, butanol. There's a branch sticking out, methyl, 1, 2, 3, it sits on the third one, 3-methyl butanol. The second one, we're going to go 1, 2, 3, 4, 5, 6, hex. Hexane, single bonds, there's a Br here and there's an ethyl here. The ethyl sits on 1, 2, 3, 4, so it'll be 4-ethyl hexane, and the Cl and the Br, 1, 2, chloro, and 1, 2, 3 on the bromo. 3-bromo-2-chloro-4-ethyl hexane. The last one is 1, 2, 3, 4, meaning butane. There's a branch that sits here. In order for you to see this, you need to draw this out. There's a branch. And the branch sits on the second one, because 1, 2, you count from this side, because this is the lowest side. 2, there's 2 here. Then it's 2-methyl butane. There's a Br that also sits on the second one. Thus, 2-bromo-2-methyl butane.